friends, welcome back to our channel. So in the previous session we have started the linked list concept. So in that linked list we have seen how to create a list, so how to display the nodes in a list. So in this linked list we will handle with the nodes in terms of nodes, right? So not an element, it's a node. So a node consists of two things. One is value, another one is the address of the next node. So we have created one structure, right? So there we have created one self-referential structure for every node, and then we have created the linked list. So you can follow the previous session for understanding the introduction and the creation of a list. Now in this session we will see the insertion operation. So how an element can be inserted in a linked list, existing linked list, right? So here we are establishing a link between one node and another node. So all the nodes need not occupy the contiguous memory locations that we have seen in the previous sessions, right? So now let us see the insertion of an element to the existing linked list. So linked list. So here we will see the three cases. The first one is insertion of element at beginning. At the beginning, right? Second case, insertion of an element at ending. Similarly, insertion of an element at specified position. So these three cases we can will see now, right? So one is inserting an element at the beginning of the linked list, and the second one is the insertion of an element at the ending of the linked list. Third one, we have to specify some position and we have to insert the element at that particular specific position, right? Now let's see one by one. Let us take one example and then we will see that, right? Now, so just to follow the previous session for creating a list. So let it be, first we have created a list with 4 elements. I'll give you here. So first element, second element, third element, fourth element. See, every element, every node is having 2 fields. One is data. Let it be 20, 30, 40 and 50. So the memory occupied here is 1000. The memory address of the node is 1000. This is 2000. This is 3000 and this is 4000. So we know that every node consists of the second field, that is a address of next node. So here 2000 will be saved here, right? So address of next node. Here the address of 40, that means 3000. Here the address of 50, so 4000. What about the last element? We know that the last element, the address will be null. So if any node consists of the null at the place of address, that we can consider it as a last element of a list, right? So this is a head, this is a head, and this is a tail. Now for everything we have to first take the node and then we have to insert it. So for that, for every node we have to allocate the memory by using dynamic memory allocation, right? So here we have to use the dynamic memory allocation for allocating the memory, so which overcomes the drawback of an array, right? So in the three cases, insertion at the beginning, insertion at the ending, insertion at the specific position, first we have to allocate the memory for the node and then we have to read the value. So this is a common statement for everything. So for in the three cases, so struct node star So this is a memory allocation. So we have to use a malloc for memory allocation. So we have to specify the size of struct node. So that means how much memory to be occupied. So that will be allocated to the element new. Now, so first, insertion at beginning. Right. Insertion at the beginning. Now, see, first let us write the output so that we can easily identify. See, so 20, 30, 40, 50. This is the last element, so null. This is the 4000. This is the 3000. This is the 2000. Right? And if you add the element here, it will be 10, and this will be 1000. So this will be the head, this will be the tail. So first this is the output, right? So after inserting a node to the existing list, so which is 10, right? So the element is 10. So 10 will be inserted at the beginning, and for this node, the address must be the next node address. That means 20. So 20 address will be here. See, it will be some 500, some 1000. So this is the address location, right? Let us assume. So this is the output. For this output, what we have to do? So first we have allocated memory for the element, and now we have to read the element. So for reading the element, simply we can write the scanf %d ampersand value. Let it be value. In the value there is a node, right? So now here after reading, the value is equal to 10. Now we have to place that in the beginning position. So first let us see, new of data, it should be filled. Similarly, new of next, it should be filled. So in the data, the value should be here. In the next, the address of the next node must be here. So initially this one, so new of data, it's automatically 10, so we can directly assign it. New of next, so in the new of next, here we have to get the address of previous node. So what is the address of previous node? Head of next, right? So hope you understood here. Head, new of next is equal to head. Automatically 1000 will be this value. If you write head of next, then 2000 will be here, right? So head, that means automatically the head address will be assigned to new of next. So automatically this will be happened, and the head will be placed here itself. So we are just inserting the element at the beginning, so head should be to the first element. So you can directly assign the new is, sorry, head is equal to new. So the three statements are required to get this output, right? So hope you understood. So initially this one is the list. So if you want to insert at the beginning, that is element 10, the 10 must be the first node, and the address should be the 20, the node 20 address should be placed at first node, right? So for that we have to write the new of data is value and new of next. So this is the new of next. So in the new of next we need the head address. So previously this element is a head. So head address should be stored in new of next. So new of next is equal to head. So this means the connection is established between the first element and second element. And now head is pointing to the second element after insertion. So we have to move head to first element. So head is equal to new, right? So hope you understood this one. Inserting at the beginning. Now let us move with the next one. Inserting at the ending. Right. So this is the head. This is the 1000. And if you want to insert here, so see, 60, null, 5000, and here it should be 5000, it should be 10. So this one is the output, right? So here if you want to insert an element 60, if you insert a node 60 at the ending, right, at the ending position. So initially the list is this one. If you insert an element 60 at the end position, so the output will be this one. Now we will write the code. So this is a common thing. First we have to allocate the memory for this new node, and we have to consider the value. We have to take the input for a value, and then we have to place. Right. See, first automatically you can simply write new of data is equal to value. So automatically that will be there. Now see this position. So what is this position? This one is new address of new, right? Address of new should be placed in tail. See, initially the tail is 50. So if you want to insert a new node, this address should be placed at tail of next. So tail of next is equal to new. Automatically the node new address will be saved into the element 50, right? And the new of next should be null because it is a last element. So new of next is equal to null, right? So with these statements the node is created, but the tail is at the last but one position. We have to move this tail to last node. So tail is equal to new. Tail is equal to new, right? So this is the statements. See, simply we are adding the element at the end, so that we are replacing this null with the new node address. So obviously tail of next is equal to new, tail of text is equal to new, and tail new of next because the new node itself is the end element, right? End node. So that's why we have to fill it with null. Tail is equal to null because the tail is at the last but one element. So tail should be positioned with pointing with last element. So tail is equal to new. So whatever the element we are inserting, the tail will be pointing to the particular last element. So this is the simple code for inserting the element at ending position, right? So once we will see all these statements, and finally we will implement a program. I will show you the implementation of linked list. So we will see the create, display, inserting at the beginning, inserting the ending, inserting at the specified position. Also in the next sessions we will see the deletion part also, right? So let us see the third one. At specific position. Specific position, right? Now let us see this one. Now, so let us once again I will write it so that right. So here 20, 30, 35, 40, 50. So here, so the address is 1000, 2000, 3000, 4000, 5000. So here it is null 5000. Sorry, right. $3,000. 4,000, 2,000. Now the position is 2,000 here. Let it be some 2,500, some other memory location. Okay, so that should be here 2,500. So here it should be 3,000. Here it should be 5,000. Right? So simply we can see this one. So if you want to insert at the position 2, so here position is equal to 2 and the element is equal to, value is equal to 35. Right. So value 35 should be inserted at position 2. Here also we can consider the index value from 0 itself. So from 0 the index starts. That means the index of first node is 0, second node is 1, third node is 2, and so on. So here, see, initially this one, so this is our list. In this list, at the second position, we are inserting the element. In the second element, we are inserting. So simply we have to establish the link. See, first consider the temporary variable because we need not move the head, right? We need not move the head, just consider the temporary element. So this is the head, this is the tail. So first we have to reach until position -1 because this position should be changed, right? Previously in the node 30, the address of next, that means the 40th address, the node 40 address is saved in the next of 30, right? Now it should be changed to new node. The new node address should be sent to the position -1, right? We have to travel up to position -1, right? Now let us consider temp is equal to head. Let us assign the head value to the temporal. Now consider the position also. So here we have to write again scanf %d ampersand position. So value here is 35, the position is 2, right? Now use the iterative statements for I is equal to 0 because index we have said that. So I less than position -1 I plus plus. So until it reaches the position -1. So just move. That means temp is equal to temp of next. So next address. It will move until it reaches position -1. So until it reaches here. Right? Okay. Right. So now the iteration is here itself. So if you place this 2500 in this position, the position of 40th node will be erased, right? So we have to follow the steps. First we have to place this 3000 in new of next. So simply one statement is common, that is new of data is equal to the value. That is common. Now next one, here in the node 30, in the second field of 30, it should be the address of new node, right? And in the field of new node, in the second field of new node, it should be the address of next node, that means a 40. So first if you place here, right, if you change this one, right, if you change this one, we can't place the address of 40 in the new node, right? So first we have to assign the node 40 address to the new node. So new of next is equal to temp of next. So new of next is equal to temp of next. So node connection is not disturbed. No connection is not disturbed. Now place this with the new node address. So next temp of next is equal to new temp of next is equal to new. Temp of next is equal to new, right? So these two statements are very important. We have to follow the same order, right? So this one, if you reverse this one, that means first if you remove the temp of next is equal to new, so if you perform this statement first, automatically here it will be 2500, right? It will be 2500 and this will be null. And what address should be placed here? Because we lost the address of the 40. We lost the address of 40. When? If you implement this statement, temp of next is equal to new, before this statement, right? So that's why first you have to establish the connection. So that's why new of next is equal to temp of next. That means 3000 will be placed in the new of next, and then temp of next is equal to new. So 2500 will be placed here, right? So this is the code for implementing the insertion operation at the middle, right? So hope you understood this one. So the three cases, so insertion of an element at the beginning, insertion of the element at ending, and insertion of the element in the middle position, I mean specified position, right? So if you understand this list concept, it is very easy to write the code. So first write down the input and draw the output. Based on the output, if you write the code, then it will be very easy, right? So we know the sequence of steps, what to be first and what to be next, right? So let us stop here. In the next session we'll go with the deletion operation. So in the deletion operation also we have to see the three cases: deleting the element from the beginning, deleting the element from the ending, deleting the element from the given position, specified position, right? So that sessions will be in the next one. So in this video, so I will just give the link of the first introduction and the creation of a list in the description section, right? So just go through before watching this insertion. So it will be very easy for you for writing the code, right? So let us stop here. If you really understand my videos, so like my videos, share my videos with your friends, and if you are having any doubts regarding this linked list, feel free to post your doubts in the comment section, so that I will definitely try to clarify all your doubts. And don't forget to subscribe to our channel. Thanks for watching. Thank you very much.